Okay, let's move on to example 2 of page 19. Example 2. At the beginning of 1990, the population of a town was estimated at 12,000. The population increased so that after a period of n years, the population was 12,000 multiplied by exponent to the power of 0.07 n. Okay, estimate the population at the beginning of 2005 correct to 3 significant figure. Alright, so in this question, the only strange thing is they just give me this. The estimate, the population was this. So this is an expression. So we just have to, how to make it similar to the previous question. We just have to let the population be represented by, obviously, P lah, because population, we use the capital letter P to represent population. So the equation we will have will be P equals to 12,000 E 0.07. So this question, they give me the number 12,000. 12,000, right, can be, is quite similar to the previous question. You know, previous question they say n equals to n naught, blah blah blah. So this question they say p equals to p naught exponential 0.07 n. So like 12,000 is like the p naught, the initial number. Why do I say so? Because when I sub in n equals to 0, I'll get 12,000. When I sub in n equals 0, my population is 12,000. So 12,000 is actually the p naught, the original amount, the initial amount. Alright, so now they want the population at the beginning of 2005. So from 1990 to 2005, how many years are there? 15. Okay, good. So I will say when n equals 15, from 2005 you take away 1990, you get 15. So when n equals 15, my population is 12,000 times e to the power of 0.07 times 5. Okay, the 5 is a power, 5 times 0.07. So what you should see in your calculator is this, 0.35. Okay, because 0.07 you multiply by 5 is 0.35. And you should get about 34291.81. But I don't want this. I will need 3SF, which is 34300. 3SF, so I look at 9. So the previous number 2 I will round up. B, the year in which population will be expected to first increase to 90,000. First increase to 90,000. Interesting question. Take note, I want it to be first increase to 90,000. So let's see. I will have to equate 12,000 E. Okay, let me rewrite properly. I want P to be 90,000. Okay, to be at least 90,000. Therefore, 12,000. P is actually 12,000 E 0.07 n, right? Equals to 90,000. So I'll divide both sides by 12,000. 90,000 divided by 12,000. 90,000 divided by 12,000 is 7.5. To get the n down, I need to log both sides. So 0.07 n will be brought down. Ln E is 1, so I don't need to write ln 7.5 here. So n equals to ln 7.5 divided by 0.07, which is, you press your calculator, you should get 28.784. 28.784. Alright, so you need n to be 28 years, 0.784 years. 784 years. Okay? That means in the 28th year, you already hit 90,000. Am I right? Because 28.784, the 0.784 means probably maybe in the 3/4 of the year. So that means about September, October, that period. So in 2018, which is 28 years later, 28 years from 1990, it will hit 90,000 population. Okay, so I will say, therefore, the answer is in the 28th year after 1990. The year is 2018. Okay? Okay, let's move on. Last question already. The value of V of a flat can be modeled by this. Okay, I believe it will be more straightforward right now. So let's see. Calculate the value of P after 5 years. After 5 years. If after 5 years the value of the flat is doubled. Value of flat is doubled. Value of flat is doubled. What do you mean by value of flat? Okay, it means the original value of the flat. First, I must know what's the original value of flat. If you do not know, then you do this. Original value of flat. I know it's actually V0 because it's always the initial, the original value. But if you don't know, then you just sub in t equals 0. So V will be equals to V0 e to the power of 0. E to the power of 0 is 1. So V will be V0 lah. So the original value of flat, is V0. Okay? Get it? So now I want double. When the original value of flat is doubled, it becomes 2V0. Understand? Yeah. So now we use the equation V equals to V0 EPT, right? Instead of writing V, I will write what? I will say when T equals to 5 years, my V becomes 2 times of V0. So I sub in 2 times of V0 equals to V0 exponential 5p. V0 and V0 can be cancelled away along both sides. 5p equals to log 2. P equals to log 2 over 5 equals to 0.138629 equals to 0.139. 3SF. That's the value of P. Okay, and P is a constant. But that means it's a fixed number. So I will prefer this value later. Okay, later when I key in my calculator, I'll use this value for part B. So for part B, the age of the flat when the value is 5 times its original value. 5 times. Okay, simple. But first thing, remember what I say? Change the equation because now I know the P value. So I say V equals to V0 E. The P value I know already is 0.13. Write a more accurate value, 8629. About 5 to 6 significant figure. Okay. So I have this. Okay, let me just be more consistent, I write what I always say, 5 significant figure. And so this I also need just 5 significant figure will do. Okay, so be more consistent. So we have this. Now they say 5 times the value. So which means what? So which means the V now is 5 times of original value, V naught. So I sub in 5 times of original value, E 0.13863T. Both sides cancel away V naught, 0.13863T. Ln both sides. So 0.13863T will be brought down. Ln E is 1, so it's equals to ln 5. T equals to ln 5 divided by 0.13863. Answer is about, okay, now this is the final answer already, so I don't need any 5 significant figure, just give me 3 significant figure, 11.6. Press your calculator, you can get 11.6. Okay, so 11.6 years. Okay, that's all for this worksheet. That's the last page already. So homework, we'll go through this in class. But of course, I'll go through the first few homework lah, 4.1 to 4.5 first before I go through this.